Hello, I'm T.Mestré, and with my colleagues V.Bodeux, we are going to present you the analysis of the article A Finance Approach to Climate Stress Testing by H. Renders, Mr. Schoenmaker, and Mr. Van Dijk. This is how our presentation is structured. First of all, we are going to introduce you the paper and the problematic of this article. Then, we will look of the models used for the analysis of the problem and the modification made to it. We will have an analysis of the result of our paper. Then we will talk about the limits of the framework, and we will end this presentation with an explanation of a precise strategy for sustainable socioeconomic systems. Our article was published in April 2020. There are three main authors: Henk Jan Renders, who is an economist at the International Monetary Fund; Dirk Schoenmaker, who is a professor of banking and finance at the Rotterdam School of Management; and Matthijs van Dijk, who is a professor of finance and a scientific director at the NEFA. As you know, there is a global warming on Earth. This one endangers most of the living beings on our planet, and this alerts some politicians. Those leaders will therefore take measures to counter this global warming, measure that will have an impact on the world of finance. The objective of our article is twofold. At first, we will understand all the potential impact of the new climate policies on the financial institution. Then, we will understand how the different industries are reacting with a new climate policy. This has already been done by other researchers, but in a black box manner. The goal here is to provide a more tractable model, more realistic and easier to understand. We will now look at the model used for the estimates in our paper. To begin with, I will present you the basic model. Then, I will show you how to define our stress model, theta, and I will discuss the limits of the Mertens model and the adaptation used in our paper to fit the reality. Then I will go on to show you how to define our stress value shock coefficient (XI). Then I will finish with some details about the data used for this model. The aim of our model is to answer the question: what is the impact of climate policy stress scenarios on the market value of debt and equity portfolios of banks? To do this, we will separate the bank's exposure into two distinct groups: debt and equity. Our model is displayed below. Let's look now how the Mertens function works in the next slide. We can define the market value as the model below. The variables are n, which is the probability of standard normal density function less than d. We have v, which is the asset value, which follow a geometric Brownian. We can define v prime, which is the v multiplied with 1 minus epsilon. We have L, which is a contractual payment, big T minus little t, which is the time to maturity. We have sigma v, which is the standard deviations of v. We have little r, which is the risk-free interest rate, and we have d1 and d2, which are functions of the variables I said before. We obtain almost the same formula for the market value after the shock, with some parameters that have changed, so this is the case for d1 and d2. If we change v by the formula I said before, and if we mix all equations, we can find this big formula. So we can see that if the asset value decrease, the theta decrease too. And we can apply the same method to find theta E, so the theta for the equality. There are three main limits of the Mertens model which can make our model underestimated. This is the case for the first and second limits, or overestimate the potential loss, which is the case for the third limit. So the first limit is that the asset value follow a Brownian motion, which are not totally the case. The second limit is that there is some cuts which are not captured by our model. And the third limit is that the recourse nature of the most European mortgage. So to adapt our model, we add a stringent default condition, which you can see below. And so this is how we present the theta E. We will see now how to define the asset value shock, epsilon k. We wanted to define with two new variables, which are tau and omega. Tau, kt, which represent the euro tax amount per ton of CO2 emission over time, and omega, which is a set of vulnerability parameters for the segment k at the time t. At first, the function is the following, but we will explain the black box function with four new variables, which are NPV, which is the net present value of physical asset K. We have gamma, which is the yearly emission connected to the segment's activities. We have R, which is the discount rate. We have phi, which is the non-zero amount of pass-through that can change over time. And now the new models therefore look like this, and we get this final asset value shock model. Before discussing the results, here are some details about the data used. Data was used to combine data of the exposure of financial institutions to different asset segments. Data was also used to estimate the vulnerability of the asset segments, and we need data to calibrate the contagion claims model. We use those data to create models to predict the unobservable volatility for a sample of firms. The sources are numerous. So at first we have the Dutch Central Bank, we have also the Eurostat Structural Business, the Dutch Statistical Office, and the Orbis van Dijk database. We will now analyze the result of our models. So we can see that there are three main results, and we will see that the authors have do some sensitive analysis that we're going to explain later. We identify three main features to create different scenarios, which are the amount of tax. So we will have a tax for 50, 100, 200 euro per ton of CO2. We have the timing of the tax, which can be overnight or phased tax. And we have the scope of the application, so they can be region of global. And for a given amount of tax, we have four scenarios. The first one is when the timing is overnight and the scope is regional. The second one is when the timing was phased in, but the scope is regional. The third is when the amount of the timing of tax is overnight, but it's applied globally. And the fourth is when the timing is phased in and the scope is global. This graph shows the estimate asset value shocked by industry in 100 carbon tax scenarios. So we can see that the main sectors in danger are the manufacture of coke and refined petroleum products, the manufacture of basic metals, and the air transport. As I said before, we can distinguish three main results of our model. The first is that the total market value losses for the Dutch banking system range between 4.5 billions and 35.8 billions. The second result is that the market value loss for the balance sheets of Dutch banks increase exponentially with the euro amount of tax. So we can see that the scenarios 1 increase more than the 2, which increase more than the scenario 3, and the scenario 3 increase more than the scenario 4. It can therefore be seen that the timing of the tax and the scope of its application will have an impact of the market value losses. The third result is that the losses for the Dutch banking sector are primarily driven by exposure to corporate loans and debts. Here, we notice that the rates are really low for detached of semi-detached houses, flat and terraced houses compared to the different other sectors. The authors give us a sensitive analysis to interpret the new results. There are three new assumptions which are made for €100 amount of tax. The first scenario, the scenario A, is when we have a risk-free interest rate of 0. The B scenarios, B new assumption, is that when the ease of which firm can adapt to the carbon cap. The last one is when we allow the firm level variation in leverage and to asset volatility. We can see that for the first assumption, it can be seen that a risk-free interest rate of 0% increase losses, and this is even more important from the last two sectors. It can therefore be said that the linear phasing timing over the tax over a period of 10 years application of the tax are more influential factors for a 0% risk-free rate. For the assumption B, when we increase the ease with which firms adapt to the carbon cap, we find that losses are dramatically less than estimated. Finally, for the assumption C, so if we follow from firm variation in leverage and asset volatility, we also seen an increase in the market losses. This is generally more important than for the scenario A, but we notice that the difference between the two extreme scenarios is less more important than for the first assumption. So now we will look at the limits of our model. The first limitation concerns the focus of our models, the second one concerns the Mertens model, and the third one concerns the potential valuation changes. As I said, the first limitation is the focus of the model. The model only focuses on the market value effect and the asset value shock, but there are other variables that affect our results. For instance, we can say that the increase of unemployment or the general equilibrium effect also have an impact on the market value effect. The consequences of this limit is to find an optimist estimate of loss. To solve the problem, we'll have to adapt our model so that it can take into account all the variables that impact the market value effect. The second limitation is the Mertens model. The Mertens model have two assumptions that are problematic for our analysis. The first one is that the model does not take into account the additional cost of bankruptcy and consider that there is no sudden jump for the asset value, which is false. The second assumption is that the parameters are constant. As with the first limit, this leads to an optimist estimate of losses. One possible improvement will be to adapt the model to take those variables into account. The third limit is the potential valuation changes. So we can see that some industries are dependent of a carbon-intensive change without being themselves carbon-intensive dependent. The impact for those type of sectors must be calculated and evaluated in our model. There are also companies that benefit for the political climate, and that needs also to be mentioned and included in our model. Now let's talk about the accuracy of strategy towards a sustainable socio-economic system. So to begin, we will discuss about the complexity of the problem. Then we will going to talk about improving the economy, and we will conclude to talking about a scientific improvement. It is clear how complex the climate problem is because there is some downside to every political decision. This is the case for the carbon tax, which causes losses that can be enormous for companies. One cannot deny the dramatic prediction for the climate, but it's sometimes difficult to fully understand the different impact of policy decisions. It's also difficult to target sectors without thinking them. Some sectors are very much affected by those political decisions, but are nevertheless very important, such as the distribution of electricity, gas. A good solution to this problem is to encourage shareholder activism, so that companies adapt on their own to avoid the government making policy that they are too difficult to manage all at once. We remain convinced that a more local approach to the economy will be drastically change the energy needs and therefore the carbon cost. It will rethink the way that the politicians think about limiting the business into climate issues. Last, one of the solutions is to use alternative to resources of alternative processes. There are some resources which aren't destructive for the earth, and some processes aren't costly in a carbon way. We have to deepen our scientific knowledge and to experiment to try to find those substitutes. It will give more information to companies and to politicians. We can also apply one of citations about of Jean Zinn, which is it is the information of the state of the planet that makes us ecologically responsible for our common future, while the need of training induced by information technology makes it essential to reorient the economy towards the human development. At last, we will encourage discussions between politicians and companies to solve as many problems as possible together. It will find less devastating compromises, and it will have to financial institutions to set risk limits. For your listening. If you have any question, you can send me a mail to the address below. Have a nice day.